Good morning, class. Hopefully you can see all of that. I think you can. Sorry for my finger getting in the camera today. All right, so I am recording this on a Wednesday morning. Wednesdays are our college t-shirt days on my high school campus, so even in this virtual setting, I try to sport some type of university look. So my Penn State shirt here today, that is actually the campus that I was born at. My parents were going to school there at that time, and I was born like right next door to the Penn State campus in this little town's hospital. So I did not go to Penn State, but I've always had a soft spot clearly for them. All right. 6-6 is going to be about solving rational equations. And I want you to tune into the key piece because, again, taken individually, each lesson in this chapter is probably pretty manageable. Okay, if I see add, I'm going to follow these steps. If I see simplify, I'm going to follow these steps. And now we're approaching the end of the chapter. And when that happens, from experience, students start to feel, I don't know when to do what. There's so many different things, and I don't know how to differentiate when I do this thing and when I do this thing. So when you see the word solve, your equation, for the first time, your problem, of course it's an equation, will have an equal sign. So you'll have two clues right there at the beginning. The instructions will say solve. You'll see an equal sign in your problem for the very first time in this chapter. And we're going to work it out until we have x actually equaling, not a hashtag, but some type of number. Okay? We want x to be equal to a number. All right? So that's our goal. So, and again, we have to work within all these fractions. So there's still rational expressions. Everything is going to have a fraction attached to it. So when I look at this very first problem here and I'm like, oh, how do I solve with fractions? And maybe you're thinking, well, if it was something like this, I know I would subtract that one to the other side, and then I would divide and divide, and it would all work out really nicely. And if you apply these steps to this problem, yes, the steps are valid, they absolutely would work, but look at immediately, if you subtract that 3/5 over to the other side, now you've got all these fractions, and you have to find common denominators, and it just gets really unnecessarily complex. And then the second we have a variable in the denominator, it gets nearly impossible to work out. So here is the strategy. You are going to multiply every term by that least common multiple, that common denominator. It is a method commonly known as clearing the fraction, and that is going to be your very first step on all of these problems. Clear out the fraction. Watch and I'll show you exactly what I mean. Between 2 and 5, my common denominator, my LCM, is 10. So what I'm going to do is I'm going to put a 10 right here, a 10 right here, and a 10 right here. And if I multiply every term in my equation by 10, it actually is a very mathematically legal thing to do. It doesn't change the value because you stayed consistent. You just multiplied everything by a factor of 10. Watch what happens next. If I have a 10 here in this numerator, 2 divides into that 10 5 times. And 5 divides into that 10 2 times. So when I go to write my second step, and this holds true for, it doesn't matter how complicated these get, when you go to write your second step, all of your fractions should be gone. So what do I have left in this first term? I have that 5 and that x. What do I have left here? I have this 2 multiplied by that 3. And in the back here, 6 times 10 is 60. So think about how quickly we went from something with 2 fractions that might have looked kind of confusing to something much more manageable. One step, your fraction should be gone. And now we just solve. Subtract the 6. 5x equals 54. Divide by 5. Divide by 5. This is reduced, so that is totally fine with me. If you want to change that to a decimal, throw it in your calculator, that's totally fine as well. All right, that's the strategy. Let's apply it here. Now we have our x's in the denominator. Still think about what that common denominator is going to be, what that LCM is. We need a 3 and an x. So I'm going to multiply here by 3x. I'm going to multiply here by 3x. And I'm going to multiply in the back by 3x. And let's see what crosses out. Here, this entire thing crosses with that. So when I go to write my next step, the only thing left is the 2. Plus, my x's cross out here. So 3 times 1 is 3 equals 10 times 3x is 30x. Again, no more fraction. Now our answers might not always look so nice. This might be even a little confusing because this is such a big coefficient in front of that variable. But your steps from kind of like how to solve 1 and 2-step equations still totally apply. Gather your like terms. Divide by 30, divide by 30. So x is going to be 5 over 30 does reduce down to 1/6, or you can write that as a decimal if you choose. Let's do it again. The main idea is that you're multiplying through by the common denominator. Now, this is the only fraction in the mix. So if that helps you, because you want to see that written as all 3 fractions, this is the common denominator. This one is going to work out just a little bit differently. So we need to put an x. Oh, maybe I should change colors. Sorry. We need to put an x right here, an x right here, and an x right there. This one, like nothing's going to cancel. So this becomes x times x, which is x squared. This x cancels with that x. So this is just plus 6. And nothing's going to cancel here because the denominator here is just 1. And so we have that. So now we have both an x squared and an x term. So perhaps maybe you're thinking, what are you doing to me here? This doesn't look as easy as that. Well, how do you solve a quadratic? You have to set it equal to 0, factor, and solve each factor. All right, so let's move that 5x to the other side. It's going to become negative when I jump that equal sign. Let's solve. Again, we need to add up to a positive 6, or multiply to a positive 6, but add up to a negative 5. So I'm going to choose x minus 2 and x minus 3. So my 2 answers here, I'm just going to bring this up to this part of my whiteboard so that I don't know if you can see all the way down there. So my 2 answers are x equals 2 and x equals 3, setting each of those factors equal to 0. Now, this brings up a great point. When you solve these with x with a variable in the denominator, like this example and this example, we have to double check for undefined values. Remember, the bottom of a fraction cannot be equal to 0. So you are going to encounter some of these questions on the homework. When you look at this original problem, I will rewrite it for you. What is the only value here that x cannot be? What will make that piece right there on in the denominator equal to 0? X cannot be 0. Because if this were a 0, the whole thing would blow up and be undefined. Neither of these are 0, so both of these answers will work. And if that's confusing to you, I have an example coming where you do solve and you get one of the answers where x cannot be, and you have to throw it out. So I just want to start introducing that idea. Let's do a few more. This is it. It can change, the variety of question can change, but the steps remain the same. And you've seen already that sometimes you have to factor. So 1, 2, 3, I think we are on D, example D, and my instructions here this morning are to solve. And so I have not done this one, 1 plus 3x over x plus 2 equals minus 6 over x plus 2. So yes, of course, this one looks just a little harder than the last one, but the process stays the same. This is the common denominator, is x plus 2. So you need to multiply here by x plus 2. You need to multiply here by x plus 2. Try to keep your work nice and organized. It does make it a lot easier. So I feel for those of you who struggle with your handwriting a little bit. So, and this first term, nothing cancels. 1 multiplied by that isn't really going to do anything, so I just have x plus 2. You can put it in parentheses if you want to. Here, this is going to cancel with that. So plus 3x, and here this is going to cancel with this, and we get minus 6. And after the first step, even though this had a higher level of difficulty, after the first step, no fraction. Okay, now let's go back up to my original question real quick and just think about what is our restricted value. What can x not be? And so x cannot be equal to -2 because we can't have that expression equal to 0. So this is the only thing that x cannot be. So if it turns out that I solve this and I get a -2, I've got to throw it out. Let's see what happens. I have 1x plus 3x is 4x plus 2 equals -6. I am going to subtract 2. So 4x equals -8. Maybe you see where this is headed. And so when I divide both pieces by 4, both sides by 4, I do get exactly what it can't be. This is where x is undefined. And so what you write for your final answer is empty set. There is no solution. It is not x equals 0. I started to write that and then I was like, no, I'm going to confuse somebody because I was going to it's not that. It is empty set or no solution. That is the answer to the question. X isn't equal to anything. It doesn't have an answer. All right, let's do another one. Example E. Just to let you know, in case you're wondering how many of these you have to watch before you see all the different types, I only have 2 more to show you. So 3. over x minus 5 plus 1 over x minus 5 is equal to 2 over x squared minus 25. And this is the most complicated one of the day. The last one is just kind of a fun fact, just an extra method, if you will. All right, so x squared minus 25 does factor to x plus 5x minus 5. So this needs to be our common denominator. So it does take just a few seconds. I would highly recommend just spending the 5 extra seconds it takes to write it next to each term, kind of small. Choose a different color so it stands out. So you need to multiply through by that common denominator. And now you're going to say what cancels. Well, the x minus 5's here are going to cancel. And I think black is easier to read than the red ink, so this is what's left. 3 parentheses x plus 5. Here, x minus 5 cancels, so what's left? Plus 1, but that's really not going to do anything, so plus another x plus 5 equals, this entire piece cancels with that, and so the 2 is the only thing that remains. So we're given something so complex looking. If you really want to impress someone that isn't at this level of algebra, show them this problem. It looks very complicated, and then all of a sudden there's no more fraction. So we've got this. Multiply it through 3x plus 15 plus x plus 5 equals 2. Add your like terms. So 3x plus x is 4x. 15 plus 5 is 20. Subtract the 20 to the other side. I'm already writing down the answer. So 4x equals negative 18. Divide by 4. You can reduce that to negative 9/2, or you can write it as a decimal. Is this one of my restricted values? It is not, because if I think about all of the denominators in my original problem, x cannot be a positive 5 because of this factor right here, and x cannot be a negative 5 because of that factor right there. So this answer works because it is not one of those values, and so we're good. All right, one more. And I don't know how many of these you will see in your online homework. I'm way more familiar with the book than I am my math lab. So in the paper copy of the book or the electronic copy of the book, there are some problems that look just a little bit different. And I forgot which letter we're on, so you can organize that. Okay, so let's say we're given a problem that looks like this. So this only has 2 terms, one on the left and one on the right. And so you can apply the method that if you don't want one more thing to have to like think about or memorize, that's totally fine. You can do this. What's the common denominator? And follow that rule and do exactly what we just did. However, if you like to always be shown the shortcut, when your problem is simply fraction equals fraction, and there are no other terms, you can apply a method that's known as cross multiply. It is different than cross cancel. And again, somewhere in your K-12 history, you probably did look at problems that looked something like this. I'm just making this up off the top of my head. And so you would get rid of that fraction by cross multiplying. And it is a nice shortcut that will apply when we get to our word problems, our application problems in the next unit. And then you would divide by 13 here. So when it is like that, but a little bit more complicated, you can still cross multiply as long as it's fraction equals fraction. So you're going to multiply 5 times everything here, and you're going to multiply 3 by everything there, and that gets rid of the fraction for you again in the first step. And then you just wrap it up. Distribute the 5 and the 3. Take the 3x to the other side, take the 10 to the other side. So 2x equals -1. And so x is equal to -1/2. What are the restricted values for this problem? X, for the undefined values, x cannot be -3 and x cannot be -2 because that would create zeros in the denominator, and so you cannot have that. This isn't those, so you should be okay. All right, so that is a variety of different types of questions. You saw one where you had to factor. You saw one where it was fraction equals fraction. So every problem just has a little bit of twist to it. And so as always, good luck. Have a good rest of your day. And I hope you are successful on your homework. And please feel free to reach out if you have questions. Thanks.